Hello everyone and welcome back to Tech with NK. In this video, I'm going to propose a solution to the exercise Refueling from CS50's Introduction to Programming with Python. I'm going to show you how I went ahead to solve this exercise. However, I just wish to provide you with a few tips or ideas that you could use while solving the exercise later on. So that said, let's look at the exercise and see what's expected from us. So in this exercise, we're expected to create a Python file, we'll call it fuel.py, and re-implement fuel gauge from problem set 3, restructuring our code as seen below. There's no real big need to go back to this exercise fuel gauge because everything has been explained for us here. So I'm just going to read the instructions here and we're going to go ahead to solve the exercise. So the first thing we need to look out for is the function convert. This function expresses a string in x divided by y format as input, wherein each of x on y is an integer and returns that fraction as a percentage rounded to the nearest int between 0 and 100 inclusively. And if x and or y is an integer, or if x is greater than y, then convert should raise a value error. So this is one of the things that we need to test for. And if y is 0, then convert should raise a zero division error. This is another thing we need to check. Then the function gauge expects an integer and returns a string, that is e if an int is less than or equals to 1, f if an int is greater than or equals to 99, and z% otherwise, wherein z is the same integer. So like we said, we're supposed to structure our code like this. We'll have a main function, a convert function, a gauge function, and at the end we'll call the function main. Then in a file called test_fuel.py, we're supposed to implement two or more functions that collectively test our implementations of convert and gauge, each of which name should begin with test underscore so that we can execute the test with pytest of test_fuel.py. We've been given a few hints in here. The first hint is to make sure to import the functions convert and gauge from the file fuel.py. And next, we're also reminded to return and not to print. And if we want to raise an error, we can do so with this kind of code, raise value error, or we can say raise zero division error. And also, we've been given this link for us to see how to use pytest to recognize if a function raises an exception or not. But I'm not going to open these because we already saw the syntax in the lecture video. And as usual, we're expected to create a folder, we call it test_fuel, cd to that folder or directory, and create the file test_fuel.py. And it's in this same directory that we're going to re-implement fuel.py. And how do we test our program? We're expected to do this twice. That's at the end of the program, we're supposed to run pytest of test_fuel.py. And the first time we are expected to pass all the tests. Then we are supposed to introduce a few errors in our file fuel.py and run pytest again to make sure that pytest is able to catch those errors, then correct those errors before submitting our file. So with that explained, I think everything is clear enough, and I'm just going to open VS Code and we're going to solve the exercise together. So this is what our file fuel.py should look like. We have the main function, convert function, gauge, and at the end of the file we call the function. So we could start by writing all the code from scratch, but what I'm going to do is to go back to our previous implementation of the file fuel.py. I'm going to explain this a little bit, then I'm going to copy some bits of code from here and paste it back in the new file to make things a little bit faster. So looking at this file, what we did was we started by creating variables or constants to save the values 99 and 1, because we remember that we need to check when the fuel is greater than or equals to 99 and when the fuel is less than or equal to 1. And our code was in a while block because we needed to run it continuously. And also we had to put our code in a try except block because the user could enter something that could result in an error or that could raise errors, like when the user enters input that's not an integer. Say the user enters cat divided by dog. So that is why we had to put the code in a try block. We use the split function to separate the user's input because remember the input will be something like x divided by y, and so we want to split x and y to get just the integers. we carried out a check to make sure that the numerator is not greater than the denominator. And this time around, instead of continuing to go back and prompt the user once more, we're supposed to raise a value error if this check is true. Then we went ahead to calculate our fuel percentage and followed up with a bunch of if-else statements to check if the percent was greater than or equals to 99, less than or equals to 1, and if not, we just return the exact value with the percent sign. So now that we have the idea, I'm going to go back to our file fuel.py and we're going to start by implementing the function convert, then the function gauge, but I'm not going to implement the function main. That's because we do not need to run this file to be able to pass this test. All we need to do to pass the test is to check the functions convert and the functions gauge, and we are not checking the function main. So I'm not going to implement it for the sake of this video, but if you want to, feel free to do so and see how the code works. So the first thing we're going to do in this function convert is we're going to split the user's input. So I'm going to create two variables. I'm going to call them x and y, and I'm going to set it to fraction.split, and I'm going to split this with a forward slash. So this should separate the values of x and y and assign them to our variables x and y. Then I'm going to try to convert the user's input into integers. I'm going to assign x and y to the int of x and y to the int of y. So this should convert the user's input into an integer. And if this fails, we should be able to catch that with an except block. So I'll say except value error. We're going to raise of value error. And remember that still in this function convert, we're supposed to check that our denominator, that's y, should not be equal to 0, and x should not be greater than y. So to do this, I'm going to use an if statement. I'll say if y is equal to 0, what do I want to do? I want to raise an exception, raise an error rather, and I'm going to raise a zero division error. And lastly, I'm going to check that x is not greater than y. So if x is greater than y, I'm going to raise a value error. And I'm using two if statements instead of an elif because I want my code to check if y is equal to 0 and then check if x is greater than or y independently. If I used an elif statement and this check passed, my code would not check if x is greater than y. So that's why I need to use two if statements so that both checks are independent. That as a result of this check, it's not going to affect this one. And then I'm going to calculate the value of the fuel. I'm going to save this in a variable or call it fuel. And all I'm going to do is to round the result of x divided by y star 100, star 100. And then I'm going to return fuel. And so this should do for our function convert. Next, our function gauge. To implement this function, all we need to do is to write a bunch of if-else statements, and I'm just going to copy the ones I showed you earlier from our previous file. And with this done, I need to modify these names. I have to change fuel to percentage and full tank to 99, empty tank to 1, and so on. Okay, so now we have if percentage is greater than or equals to 99, if percentage is less than or equals to 1, and at the end we're printing percentage. But in this exercise, we are not supposed to print, rather we're supposed to return. So I'm going to change all of these print statements into return statements. And this is what our function gauge should look like. If percentage is greater than or equals to 99, we return F. If it's less than or equals to 1, we return E. And else, we're returning the actual value of the percentage as a string. But come to think of it, we don't even need this else statement here. All we can do is just return at the end here, and that should still work just fine. So go ahead and save this file. Then I'm going to go to my file test_fuel.py, and we're going to implement this file together. And as usual, the first thing we need to do in this file is to import our functions. So I'm importing from fuel, import gauge, and comma, import convert. And also, I'm going to import PyTest. And as I mentioned earlier, there are a number of things we need to check for. We need to check for the value error. We need to check for the zero division error. We need to check for the second value error because you know there are two cases when the user enters an input that's not an integer and when the numerator of the user's input is greater than the denominator. And then we also need to check when the result is supposed to be an F, we need to check for an E. And lastly, we need to check for correct fuel output as a string. So I'm going to create my first function. In this function, I'm going to test for a value error. I'll call this function test underscore stir underscore input. That's if the user enters an input that's not an integer. That's if the user's input is like cat divided by dog. And to do this, we're going to say with pytest dot raises in bracket, we're going to check for the value error. We are checking convert of, let's say, cat divided by dog. So this means that if we run the function convert with input like cat divided by dog, our code should return a value error. And that's what pytest is expecting from this function. I'm going to copy this and paste it a number of times. And I'm just going to modify these functions a little bit. Like this one, instead of testing for a string, I'm testing for a 0 input. And instead of raising a value error, what we want to raise is a 0 division error. And the type of input should be convert of, let's say, 1 divided by 0. And for this last function, I'm going to remove this, or rather I'll remove all of these, and I'm going to call the test of improper fraction. And this is going to remain with pytest.raises of value error. And instead of checking cat divided by dog, I'm going to say 5 divided by 4. So these three functions should be able to check all the errors that could result from this code. Then I'm going to create another function. I'm going to call this function test underscore convert. And in this function, what I want to do is to assert, we're going back to our keyword assert, that convert of, let's say, 1 divided by 2 will be equal to 50. Then I'm going to copy this and paste it a number of times as well. I'm going to modify this function name. Instead of saying test of convert, I'll say test of full tank. And I'm testing that convert of, let's say, 99 will be equal to, let's say, uppercase F. And let me adjust this. Okay. And in this other function, I'm going to test empty tank. Empty tank. This should not be in uppercase. So let me remove this. Empty tank. Parentheses. And I want to assert that, oh, not convert, rather gauge. Gauge of 1 divided by 2, no gauge of, let's say, 1 will be equal to the string uppercase E. And this should not be convert, this should be gauge. And these should not be strings because gauge does not expect a string, it expects an integer. And lastly, I'm going to call this other function test of gauge. And I'm going to test that gauge 50 is equal to the string 50%. So let me put this as a string. And I think this should do for our file test underscore fuel.py. So I'm going to save this or open up my terminal and we're going to test this code together. Oh, first I have to cd to the right directory, cd to test underscore fuel.py. No .py, sorry about that. And we're going to run pytest of test underscore fuel.py. Oh, and it says cannot import gauge from fuel. Let's see if I come back to fuel.py. Oh, gauge is AU, and I wrote UA. Oh, my bad. I'm sorry about that. Let's say AU. Come back down here and let me remove this. Let's say AU. Here too, AU. And here as well, AU. So if I save this and I run this again, and as we expected, we passed all our 7 tests. So if we want to introduce a few bugs in this, let's say I come here and instead of returning fuel, or let's say in the file, or rather in the function gauge, let's remove this percentage sign here, save this, and run this again and see what happens. And yep, as we expected, we failed 1 and passed 6. And as you can see here, we are trying to assert that 50 is equal to 50%. But like we can see, this 50 here does not have the percentage sign. And so all I need to do is to come back here and reintroduce the percentage sign. If I save this and I run this again, and all 7 tests pass. Well, there's so many other ways that we could introduce bugs to this program. Like you could invert this F and E here. You could change this to strings instead of integers. There are just so many ways. But for the sake of this video, I'm just going to leave this here. If you have any questions, feel free to leave them in the comment section below and I'll be more than pleased to answer you. If you enjoyed the video, do well to hit the like and subscribe buttons, and I look forward to seeing you in my upcoming videos. That said, have a good day.